All right, hey guys. What I'm about to do over the next couple of minutes is to walk you through the notes. Now, let me just say this. For those of you that were on the field trip or on vacation this last week, um, I've already given the notes to everybody. I've already written them out. So what you could do to help yourself is to go ahead and just maybe write down a couple of notes that you think are the most important things. And then on Tuesday, I can give you the actual notes there. So I wish I would have had them ready for you before you left. I didn't. I apologize. But I think you can pick up on the gist of what we're going to be talking about, because a lot of what we're talking about today has roots in what we've already talked about in previous lessons here, closer to probably the beginning of the second quarter. So moving on to today's notes, we're working in 11.2 talking about transformations of quadratic functions. Okay. And so what I'm going to do, I'm going to come down here to this graph here and kind of show you what's going on. Now, you'll notice what I did here. I made a chart up. Now, the parent function in this case is f of x equals x squared, okay? And I graphed that out over here. And you'll notice when I plug in 0, 0 squared is 0, so that's why it's at 0, 0. Okay, we can see that right there. When I plug in 1, 1 squared is 1, so I've got that right there. Plug in 2, 2 squared is 4, so I've got that right there. And then mirrored it onto the other side because this is the axis of symmetry. Okay. Now, as I look at the next part, we've got g of x and h of x. Now, you'll notice it's x squared plus 4. And all we're doing is taking x squared and adding 4 to it. And so basically, each of these values are going up 4. So what's the result? What's the transformation that's taking place? Well, it's a translation up 4 units. 1, 2, 3, 4 here. 1, 2, 3, 4. It's kind of cool to see it, from one point to another. You can actually see how high up it's going. Now, for the next one, x squared minus 3, if you take each of these x squared values and subtract 3, you have what's left over right here. Okay, and so again, what's happening to the parent function to get to h of x in this case? We're going down 3 units. So whenever you have something beyond the x squared, plus or minus, it's up or down that length. Okay. Now, again, we've talked about this other part in previous lessons as well. You'll notice here that I chose to choose different points over here because I felt like I wanted to stay on the graph, okay? And so I chose better points that represented it. But basically, here's my parent function right here, okay? These are the x squared values. And if you add 4 and then square, order of operations says do your parentheses first and then square. If you add 4 and then square it, what ends up happening is this. Let me think here. Okay, here's my x value. If I add 4, that is 1, and 1 squared is just 1. Okay, there it is. Okay, so negative, yeah, there it is. Sorry, I was having trouble finding it. But if I take that value, add 4 to it, and then square it, I get 1. And so as a result, at negative 3, 1, 2, 3, I'm up 1. Okay. Now, what I want you to see is that this point right here was moved over 4 units, okay? And it went left and not right. That's the key here, guys. We're the opposite direction of what's going on here, okay? So if I were to take negative 2 plus 4 gives you 2, and square that, that gives you 4, all right? So we have that there. So again, negative 2, positive 4, right there. And this point right here is actually moved over to this point because this is, the shape of the parabola, that corresponding point there, okay? Now this point right here at negative 3 is actually moved all the way over here at negative 7, okay? Is it negative 7 or negative 6? I think it's negative 6, okay? And it's moved 4 points. Yeah, it was negative 2. So it's moved 4 points to the left, okay? So again, this value comes out as the opposite value in my mind because that helps me think left. Okay, I'm moving left 4. Likewise, or conversely, if we're subtracting something, we're going right that distance. So if I look here at the vertex and the corresponding vertex here, as I graphed out h of x, this function right here, this vertex point moved over 3 units. This point right here moved over 3 units. Okay, and you can see that played out. At 1, it is positive 4. Okay, at 1, 2, 3, 4. At 4, it's positive 1. Again, 4 minus 3 is 1, and 1 squared is just 1. Okay, so again, 4, 1 is our corresponding point right there. So I hope that makes sense based on other things that we've looked at this year. Some of the other things, we're going to actually talk about some dilations here in just a moment. That is where things get a little dicey, a little different. Okay, so as I move down, here's what I'm seeing. I see a negative 2 right there. What does that mean? It means I'm going down 2. Here I'm seeing a positive 9. What does that mean? I'm going up 9. Okay, my vertex is shifting up 9 instead of being on at 0, 0. This one right here, I'm at plus 4, so I'm going up 4. Okay. Now, inside the parentheses, because we do the opposite direction here, it says plus 6, so I'm actually going to go left 6. Okay. This one here is minus 5, so I'm going to go right 5. This one right here is minus 7, so I'm going to go right 7, the opposite value, that distance. Now, the reason why this is important is this. This is actually what's called vertex form. I know my vertex, and you might want to write this down, of this equation right here is going to be at left 6 and up 2. Okay, oh, I went wrong way. Down 2, sorry. Okay, so that's my vertex, and I can build off of it from there. All right. Now, the nice thing is, we're going to talk in a little bit how this is the growth factor here. That's a growth factor of 1. There's no number there. So I'm opening upward. So this is a minimum value, and I'm going to open upward from there. Okay. My vertex for this one, okay, is going to be right 5 and up 9. So right 5 and up 9. That'll be my vertex. And again, it's going to open upward because there's a growth factor of 1 right there. Now this last one, we're going right 7. So my vertex for number 3 is going to be 7, and I'm going up 4. Okay. Now the difference is I have a growth factor right here of negative 1. All right. So this is going to open downward. I put invert. Okay. You're going to find out in a little bit. We're actually going to use the term reflect either across the x or y axis there. Okay. Now, moving on to some other problems. This is where it can get a little dicey. So hopefully this makes sense to you. If you look at what I've done, here's my parent function again. I'll try to make this blue. Okay, I know it's hard to see, but this function, as I trace it, pay close attention here, is my parent function. Okay. Now, what I notice here is that it's going to be 3 times x squared. You do the x squared first, and then you multiply it by 3. So what happens here is this. 1, plugging 0 in doesn't change, so my vertex remains at 0, 0. Okay. But if I go to, let's say, negative 1, negative 1 squared is positive 1, multiplied by 3, you get 3. So instead of going over 1 and up 1 like we did here, we're going over 1 and up 3. 3 times as tall as it was before. I wonder if that's just a coincidence. Let's look at negative 2. If I plug in negative 2 here, negative 2 squared is positive 4 times 3, which is 12. So instead of going over 2 and up 4, I'm going over 2 and up 10, 11, 12. Okay? So what does that mean? Again, the vertical growth is 3 times as big. This was 4, now it's 12. So I wrote down here, this is a vertical stretch with a growth factor of 3. Okay, it's 3 times as high right there. Now, what happens when it's less than 1, between 1 and 0? Well, if you look here, I'll go to negative 2. I chose these values here, and again, I plugged them into Desmos. So, you can do that real simply. But if I plug in negative 4 right here, negative 4 squared is 16, positive 16. And a fourth of 16 is just 4. So when I'm over here at negative 4, I'm up here at 4. Now, if you think about it, the corresponding point, if I'm at negative 4 and I square negative 4, that's 16, I'm actually only a fourth of it vertically. So we say that is a vertical compression. When it isn't growing as fast or faster than the parent function, it's compressed with a growth factor of 1/4. Okay? Oop, can't really see that there. With a growth factor of 1/4 right there. So it's a fourth as high as the parent function. Okay? So here's the rule down here. When you have g of x equal to ax squared, no parentheses, okay, when a, the absolute value of a, is greater than 1, this is going to be a vertical stretch. When the absolute value of a is between 0 and 1, it's a vertical compression. Okay, it compresses. So it doesn't grow nearly as fast. All right. Now, I hope that made sense, because it's not very, it's pretty direct on what we just talked about there. Now, here's where, again, let's see if you can pick up on what's going on here. Here's my parent function. I'm going to trace that real quick. Okay, that is my parent function right there. Okay. Now from here, I'm going to use g of x, which is this. I'm going to plug in negative 6. Now half of negative 6 is negative 3, and then I'm going to square that. So negative 3 squared is positive 9. Okay, so at negative 6, 1, 2, 3, 4, 5, 6, I'm at positive 9 right here. Okay. Now the corresponding point was right here. The axis of symmetry is right here. So if you think about it, from the axis of symmetry to that point, we're over 1, 2, 3. From the axis of symmetry to the corresponding point, we're over 6. So if you think about it, this is actually twice the distance from the parent function to the axis of symmetry. So what they say is this. If you notice down here, I put the growth factor is 1 over the absolute value of a. Okay? What that means is this. If you put 1 over the a value, okay, the absolute value is just still that value, so 1 over 1/2 gives you 2. The growth factor was 2. It's 2 times as far horizontally. Okay? If we look at this one here, another pair of points that I've graphed out here, this is 2 units over horizontally. This is 4 units over horizontally. So the growth factor, it's stretching twice as much from one to the other. Okay? So as I look at this one, you would think with a 2, it would stretch further or faster, but that's not the case. Here's what happens. I went ahead and did, let's plug in negative 1 right here. 2 times negative 1 is negative 2. Negative 2 squared is 4. So we get this negative 1. Actually, let's do positive 1. Positive 1, 4. We're right, where am I here? Positive 1, 4. We're right here, 1, 4. Now the corresponding point from the parent function is this one right here. And you'll notice here that this growth factor, it's half the distance the parent function's growth factor is. The parent function is 2 units away from the axis of symmetry. The h of x is 1 unit away. Okay. If I go up here, the corresponding points, the parent function is 3 units away. This function is 1.5 units away. And so as a result, the growth factor is 1/2. Notice here, just like we did down here, if I plug in the a value, 1 over 2 gives you the 1/2. Okay. So instead of we're stretching it horizontally, we're actually compressing. We're bringing it in to the axis of symmetry. We're compressing it. Okay. Now, that was, if you got that part right there, we're pretty much done. I mean, the other stuff I'm about to share with you is just a built off of that. Okay. So you'll notice in this next one there are no parentheses. So we're talking about a vertical, influence here by the fraction. Now, since it's less than 1, vertically this is compressing, okay, meaning it's not rising as fast, it's wider. Over here, we're greater than 1, and so it's stretching, it's growing faster than the parent function is. Okay, it's going to be narrower. Now, if you notice or remember this from before, I always said that this was inverted, okay, which it is. Here you've got your original parent function right here. We're inverting it. We're going down here. But really, what are we doing? We're reflecting across the x-axis right here. So you'll notice here, whenever you have a negative out in front, like this, with no parentheses, you are reflecting that parent function, okay? Now, to finish this all up, I got one last thing that I wanted to share with you, and that's this. Again, we have a negative, but you'll notice the parentheses, okay? And this is where it gets a little sketchy, okay? Inside the parentheses, remember we talked about that has a relationship horizontally, all right? So what I did was our parent function is right here again. I'm just going to highlight that for us. Parent function. And g of x, all right, if I plug in a -1, -1 times -3 is +3, and then we're squaring that to be 9. So -1, 9. The horizontal, remember, this is closer to the axis of symmetry right here. In fact, if I look, the parent function was 3 units away. This one's just 1 unit away. So it's 1/3 the distance from the axis of symmetry. There's a horizontal compression. It's coming together, right? And so, yeah, we've got that 1 over a, and we see that there, okay? Now, you'll also notice that there's a negative out here. Well, how did that play out within this picture right here? Well, what's happening, and if you didn't know this, you wouldn't recognize it, and I wrote it down here. It's actually a reflection across the y-axis. So with this being the y-axis and the axis of symmetry, it just flip-flops the two, okay? Just one to the other, okay? So that's what you need to know. When it's inside the parentheses, it is a reflection across the y. If it's outside the parentheses and it's a negative, it's going to be a reflection across the x. All right, now to finish things off, I have vertex form, okay? This is important to memorize, okay? The vertex form of a parabola. We're going to be using that quite a bit. These two parts are super important. They will tell us the vertex of the parabola. I already showed you that on this page right here at the very top. You've got your vertex form of all these parabolas here, okay? Now, as far as the a value is concerned, since it's outside the parentheses here in the vertex form, it's only a vertical compression or stretch. Or think about it this way, it's growing growing at a growth rate of whatever the a value is, okay? So if that a value is between 0 and 1, then we have it slows the growth rate, and it's going to be a wider parabola. If it's greater than 1, did I say less? Let me repeat that. When the a value is between 0 and 1, it slows the growth rate, and it will be a wider parabola. When the a value is greater than 1, it will quicken the growth rate, and it will be a narrower parabola. Okay? So with that being said, you do have some practice problems that you can find in Schoology. I'm going to go ahead and post those, and you let me know if you have any questions. Okay? Hey, I hope you have a great day. Again, I hope you did this before Monday because I have no idea what to expect as far as the digital realm. But yeah, looking forward to seeing that eclipse. We'll talk to you later. Bye.